Let's go over building complex models with Keras. It involves combining various layers, activation functions, loss functions, optimizers, and other components to create neural networks tailored to specific tasks and requirements. Let's explore in more detail how to build complex models with Keras. The first, model architecture. Building complex models often requires designing architecture with multiple layers and connections between them. Keras allows the flexible construction of architectures using its sequential model or the functional API. Let's look at the example of a sequential model here. So from TensorFlow.keras, I'm importing sequential. Then from TensorFlow keras.layers, I'm importing dense, con2D, max pooling 2D, and flatten. Then I create the model variable and pass it the sequential by passing the convo.td, having 32 parameters, kernel size is 3,3, activation is relu, input shape is 28 by 28 by 1. Next, we give the max pooling 2D pool size is 2 by 2. We give the convo 2D 64, kernel size is 3 by 3, activation is relu, max pooling 2D for this is pool size 2, 2. Then we flatten and then dense 128 activation relu, dense 10 activation softmax. Now compile this entire complex model by calling the compile function, and inside that we're saying optimizer is Adam, loss equal to sparse category cross entropy, and metrics equal to accuracy. Then you can print the model summary by calling the model summary function. And an example of a functional API looks something like this, where you first import model from TensorFlow Keras and then import con2D, max pooling 2D, flatten and dense from the Tensor Keras layers. Let's define the input layer by saying inputs equal to input shape of 28, 28, 1. Define the convolutional layers by saying con1 equal to con2D, 32, kernel size 3 by 3, activation relu, and pass the inputs. Pool 1 is max pooling 2D, give the pool size equal to 2 by 2 and conv1. For conv2, we say conv2D 64, kernel size 3 by 3, activation relu, and pass the pool 1. And for pool 2, max pooling 2D, pool size equal to 2 by 2 and pass the con2. Next, flatten the layers by calling the flatten function on pool 2. Next, we'll do the dense layers, where we call dense function with 128 activation relu and flatten, and dense function 10 with activation softmax of dense 1. Next, once we have that outputs, what we do is we define the model by calling the model function, pass the inputs in input and outputs to output. Next, we compile the model by calling the compile function, optimizer Adam, loss of same sparse categorical cross entropy, and metrics of accuracy. And then we print the model by calling model summary. Now, the next step is multiple inputs and outputs in this case. Complex models may involve multiple input or output branches. Keras allows you to handle such scenarios using its functional API by defining multiple input or output layers and connecting them appropriately. Shared layers. In some architectures, you may want to share certain layers between different branches of the model. Keras enables this by creating layers and reusing them across multiple parts of the model. Custom layers and loss functions. For more specialized tasks, you can define custom layers or loss functions by subclassing the appropriate Keras classes and implementing the desired functionality. Model subclassing. For maximum flexibility in building complex models, you can use model subclassing to define custom models with custom forward passes. This allows you to implement complex architectures and training loops from scratch. Now, building complex models with Keras involves leveraging its versatile capabilities, including the sequential model and functional API that we saw, in custom layers, loss functions, and more. By combining these elements creatively, you can design and train neural networks tailored to specific tasks and requirements, whether it's image classification, natural language processing, or other machine learning tasks. Experiment with different architectures and components to find the optimal configuration for your problem domain.